Let us analyze speed time graph in details. Here is a request from our GCSE students. They want to understand speed time graph, how do we find acceleration, and how do we relate it to distance. Well, let me remind all GCSE students that we have a lot of material for them on our YouTube channel. You can actually contact me on globalmathinstitute@gmail.com to really understand or master most of the topics discussed in GCSE and get ready for extended level courses. You can also search my YouTube channel by just typing out Anil Kumar, the topic name of your interest, and playlist. You'll get hundreds of videos in the playlist. We deal with all the topics which you have in GCSE, and we have more than 5,000 videos absolutely free on our channel. Now, let's begin with solution of the question at hand. The question here is the figure shows speed time graph for a car traveling along a straight road. Round answers to tens. Part A, find acceleration of the car in the first 3 seconds. Find distance traveled in the first 10 seconds. Part C is after t minutes, the car travels 248 meters. Find t. The graph is given to us. The car starts from rest at origin on this graph and accelerates to another point. Let's label these points. Let's say accelerates to A and we're tracking up to point B for the first 20 seconds. You can always pause the video, answer the question, and then look into my suggestions. Find acceleration of the car in the first 3 seconds. That means, well, this is 5 seconds, so we want acceleration at this point. As you can see from the graph, acceleration should be rate of change, right? So part A, which is acceleration, basically is rate of change. Or gradient. Now this gradient is same at any point from the origin to A, right? So you can also use the value which is given to you. Speed here is equal to 16 meters per second, right? So it reaches from speed of 0 meters per second to 16 meters per second in 5 seconds. You get the idea. In 5 seconds. So the rate basically or acceleration is equal to change in speed, which is 16 minus 0, over change in time, which is 5 minus 0, right? So that's what you get. And remember, you have to answer to the nearest tens. 16 divided by 5. So 5 times 3 is 15. 1. 5 times 2 is 10. So acceleration is 3.2 meters per second square. It is important to include units. So acceleration here, rate of change of speed in the given duration of time. Since it is a straight line, it is going to be constant at any point in between. So purposely, I have taken here 3 seconds and not 5 seconds, as could be the case in normal questions. So this becomes slightly difficult than the normal question. And that's the reason why the student has shared this problem with me. Now let's move on to part B, where we are trying to find the distance traveled. Now, when you look at the graph, what is the distance traveled from speed time graph? So, distance traveled is basically area under the curve, right? That is the distance traveled. So, when you want distance traveled in 10 seconds, then the 10 seconds is right there, right? So, we want to find the area under this curve from, we said this point is AB. Let's call this point as C, right? So, that is the area we're looking forward to. You can divide this area into two portions, or you could use trapezoid to find the area, right? So I'll rather do it in two portions. One is this, where it accelerates, it is like a triangle, correct? And the other is the rectangle. We can add these two areas, correct? You could also use trapezoid formula to find the area, correct? So area under the curve for first 10 seconds gives you the distance traveled, and that too in meters, right? So area of the triangle is half base, which is from 0 to 5, times height, which is 16, plus area of rectangle, which is from, let's use another ink, 5 to 10, which is 5 units, times the height, which is 60. You get the whole idea, right? So remember, the velocity or the speed is 16 meters per second here, right? So you can now calculate 8 times 5, which is 40, plus 5 times 6, 30, and 3, 90. So it gives you a total of 130 meters. So that becomes the exact value. However, we want the answer to tens, so it is a good practice to write this as 130.0 meters. You get the whole idea. So if you really want to get full marks and excel, it is important to follow the instructions and then reply perfect. So we got the area up to for the first 10 seconds, right? So these are your first 10 seconds, correct? You could also use the trapezoid formula. So area of trapezoid will be parallel side distance is equal to 16, and A and B are, you can measure these, 5 and 10, right? So trapezoid area you could also calculate as half of parallel sides. These are your parallel sides, correct? Length being 10 and 5, so 10 plus 5, right? Times the height, which is 16, correct? So that will also give you the same area you can verify. So either split the whole figure into triangles and rectangles, or you could use trapezoid as we have shown you here. I hope that makes sense. Let's move on and take up part C, which is kind of tricky. So, after t minutes, car travels 248 meters, find t. So basically, we want to now find time for traveling 248 meters, right? So we have already found the area of this one, right? How much was this? This was area of triangle, right? Which is triangle area was half base of 5, which is within 5 seconds, right? Height of 16, which is right there. Meters per second, speed. And that was 8 times 5, 40 meters. So that area, which translates to distance. So distance in first 5 seconds. In 5 seconds. Is it clear? That we found. Perfect. Which is 40. Now we want 240, right? So how much remain? So remaining distance. So this is like D1, correct? Now we want to find D2, correct? So We know the total distance is 240, right? 248, which is 40 plus some distance d2. So from here we can say 248 minus 40 equals to extra distance which we want to figure out. So that is 208, right? So since the car is moving at the speed of 16 meters per second, how much time will it take to cover 208, right? So let's find that time, right? So let's find this time. T will be distance over speed. Distance we want 208 divided by the speed of 16, correct? So that will give us the distance which we are looking for, but this distance is going to be in seconds. So 16 goes one time and 48 is 3. So we want 13 more seconds, right? So now let's move on to new page. 5 and 13 total time is. So I hope this part is absolutely clear. We made it simple by finding out area of the rectangle, which is going to give us additional distance, right? So 208 more than 40, which was covered during acceleration. Perfect. So now let's move on and convert 18 seconds to minutes because t is time in minutes, correct? So 18 seconds will be equal to 18 divided by 60, and then you get time in minutes. So that is the value of t which we are really looking for. Perfect. You have to write it in minutes. So you can now simplify this. Dividing both by 6, we get 3 over 10 minutes, and to one decimal place we get 0.3 minutes. So you see how we have converted the units and written the answer in minutes. I hope that makes sense. So feel free to contact us, go through our videos. There are many videos which could help you in different topics to master. Thanks for your time and all the best.